And so now we're gonna continue, right? So let's check. We did this. Let's look at the first pandas has no read CSV. Oops, I put them in capital. That's a CSV, sorry. And let's also just print the first 5 elements. Name. Oops, names. Sorry, too many mistakes. Sorry, that's names, not name. It's with the plural. And so now you can see that we have built the data frame. So messages is our data frame. We can see the name of our column label and the name of our column message. And each one represents a message, right? This is going to be our input value, right? And we want to be able to train it so that we can be able to predict the correct solution, which is ham, spam, ham. Okay. So now what we wanted to do is let's look at the full description of this data frame. So remember that data frames have this model, method called describe that tells us everything about the data frame. So this is telling us that there's a count of 5,472 labels, and each label has the message, which is good. Unique. So there's 2 unique values in here, right? There's 2 unique values, meaning that we either have ham or spam. So those are the 2 unique values that we have in this table. Now there's 5,169 messages that are unique. That means that some of them are the same. The top one that is repeating is the ham, and the top one that is repeating is the sorry, I'll call you later. So they are connected. Frequency of repeating is 4,825, and then the frequency of sorry, I'll call you later, it will be 30. All right, so now the next part would be we want to be able to use the group by to describe that by label. This way we can begin to think about the features that separate ham and spam. So we're gonna use a messages, right? That's our object, and our method that we're gonna use is group by. And what we wanted to do here is we want to look at the label and describe the information about that. So we want to look specifically at the 2 information separated. Like, let's see, we want to see how the ham information separated from the spam information are. So for example, here we are separating the information that we're given, the messages, into 2 groups, and we're separating by the labels. And remember the labels, we only have either ham or spam, so we're going to create 2 groups here. We have 2 groups, one for the ham and one for the spam. And we're looking at the count. How many hams do we have? Well, we have 4,825. How many unique values do we have in the message? Well, we have 4,416. The top one that repeats is sorry, I will call you later. And then the frequency of that one is 30. And then the spam as well. We're going to count how many we have. We have 747. Unique, 653. Top is please call our customer service representative, and the frequency is 4. So now this is not a very good balance, right? Usually we want to have an equal amount of spams and ham, but this is from it's probably a single person messages, or so that's probably why. As we continue our analysis, we want to start thinking about the features we're going to be using. This goes along with the general idea of feature engineering. Remember, we keep talking about feature engineering. It's something that is crucial for processing their data, especially for data science or machine learning. We need to be able to make sure that we look at the features that are going to make the biggest influence in our data. So some of those features we can actually create. We can actually create some of those features. For example, the length, the frequency. Those are things that can be powerful to determine some of to be able to make a prediction on whether the message is a ham or a spam or any other context. So the better your domain knowledge of the data, the better the ability of engineer more features from it Feature engineering is a very large part of spam detection in general, and I encourage you to read out on the topic. Let's make a new column to detect how long the text messages are. So here, what we're going to do is we're going to create a new column that tells us how long the message is. And the way we're going to do that is by saying messages, right? That's the object. And we're going to do group by. And we're going to group by the labels. And oh, sorry. No, that's no, I was thinking about the other one. Oops. So what we're going to do is we're going to create a new message. Sorry, messages. Length. So this is the new column that we want to create. So if we ever want to create a new column, all you have to do is just call your object, put in brackets, and then call in quotations, put the name of the column that you want to create. That's all you need to do, and that will create a new column. So it's very easy to do, and that's one of the powerful tools of data frames, is that it makes it really, really easy to do things. So in this case, what we wanted to do, the value that we want to assign into this message length is the messages, where we're going to take the value of the messages and we're going to do a count. We're going to apply a function to be able to count how many characters does the message have. When you call the apply method, what you're practically doing is you're saying that you want to apply a function to this data. So right now we're looking at the messages column, and what we wanted to do is we want to apply a function to it. And so the function that we want to apply is called the length function, which is already built in Python. And we're gonna look at the messages head. Oh, sorry, length, and we're gonna look at the head. So that's gonna give us the top 5. Oops, messages. Did I misspell messages? Message. Oh, sorry. This is message, not messages. Sorry. All right. Oh, so this is how our our messages, but not. I actually want to see the messages head. All right, there you go. So now we can see that we added a new column, which is the length column. Now we can visualize this with the tools that we have learned before with matplotlib, pyplot as plt. So we're going to use the matplot as plt, and we're going to import the seaborn as NSS. And then we're going to use the matplotlib to be able to draw. And so it looks like it's fine. And what we're going to do is we're going to apply into our messages length. We're going to apply the plot. We're going to plot on that, and we're going to choose how many bins we want to be able to see. So in this case, it's fine if we just do 50 bins. And what kind of graph we wanted to do is going to be the histogram. Let's see if that works. Oops, I forgot to do inline. All right, so let's try this again. For some reason it wasn't working, but now it's working. If it doesn't work, if you don't see it in your picture, you can also do plt.show, and that should also allow you to see it. As you can see, if I actually call this method, it will do it. Okay. And so now what we can do is we can play around with the bin size, and looks like the text length may be good feature to think about. Maybe we can try to explain why the x-axis goes all the way to the hundreds, and this must mean that there's some really long research. So notice that we didn't choose the length of the x-axis. So let me grab my pen. So notice that we didn't choose the length of our x-axis nor the y-axis, but it's doing it for us automatically. So the way this has happened is because there is a value far off at the 800. And the way we can figure that out is by doing messages dot length dot describe. So what we want to see is specifically on the describe column, what are the maximum values. So you can see the maximum value happening at 910. So that means that there's a value all the way here of that a message that has 910 characters, or yeah. So we can actually look for that message, and the way we can do that, the way we can find that message is by calling the data frame, and then looking specifically at the messages that has the length of 910. So what we can do is we can look for the index value, or the column, sorry, the row that has 910 characters. And from there, this is going to give us that message, but it's not going to necessarily give us the it's not necessarily going to give us the it's going to give us the row, but it's not going to give us the actual message. And the way we can get to the message is by saying we're going to look at the message column of that row, and we're going to look at specifically at the column 0. And let's see. So we can see that we get this. This is the message that has the biggest. So they send him, or the person, a message that has 910 characters, and you can see that message now. So we can also see the differences in length between the messages. So we can compare the two of them and see which messages, the ham or the spam, have how long the characters, the length of the messages are. And the way we can do that is by doing messages we're going to create a histogram with the columns be equal to the length, and we're going to separate by the label. We're going to have 50 bins. We can change that to whatever number of bins you want, and then the fig size is going to be 12, 4. So we want to have a size of 12 by 4. Don't forget the equal signs, and then we can press enter and see our histogram. So you can see here, this is a good way to analyze the differences between our spam and our ham. We can see that the ham, most of the messages are within 200 characters, while the spam, the average is around 150 characters. So you can see that this is actually more like closer to 50 characters, right, in the per message, and then the spam is close to 150. So you can see that there's a big differences in the length between the spams and the actual messages. So it's interesting to see. So we can see that the spams tend to be longer messages. Okay. Now let's actually do some pre-processing of these messages. We talked about some of the concepts that we might be able to do in the lecture PowerPoint that allows us to be able to process some of this data. There's some characters or some words that do not add any strength to the value of the message that would allow us to determine if it's a spam or an actual message or not a spam. And so we want to be able to clean up some of those words. We want to remove some of those words to make it a lot easier. Because remember, the goal for us is to convert the messages into a vector, and we want to remove anything that it doesn't add value to the message. And so our main issue is with the data is that all the text is that it is all in the text format strings. The classification algorithm that we learn about so far will need some sort of numerical feature, a vector, in order to perform the classification task. There are actually many methods to convert a corpus. Remember, a corpus is the messages, right, to a vector format. The simplest is to use the bag of words approach. We talked about that in the lecture PowerPoint, where each unique word in the text will be represented by one number. So we want to be able to categorize and be able to determine if any of the words are repeating as well. In this section, we'll convert the raw message, which is a sequence of characters, into vectors, sequence of numbers. As the first step, let's write a function that will split a message into individual words and return a list. So we can do that. We have done before that. We also remove we're going to remove very common words like the, a, etc. To do this, we will take advantage of the NLP library. It's pretty much the standard library in Python for processing text, as a lot of useful features. We only use some of the basic ones here. Let's create a function that will process the string in the message column. Then we can just use apply in the pandas to process all the text in the data frame. First, remove punctuation. We can just use the advantage of Python built-in strings library to get a quick list of the possible punctuation. So what we're going to do right now is we're going to remove all the punctuation, so that way that can that's part of the cleanup, right? We don't need dots and commas and semicolons and double points, parentheses and stuff like that. That's not gonna add any flavor to the message, right? It's not important. We just want to look at the most important words to be able to determine if this is a spam or an actual message. And so what we're gonna do here is we're gonna import string, and then we're gonna create a message. Right. So right now I'm gonna show you guys what's the idea. I'm gonna show you guys an example. If we have example, let's call it example message, and we have notice. We can see here we have the exclamation, the two dots. It has punctuation. And so our goal is to be able to remove every punctuation. So I want to call it non-punctuation. Oops. And I'm going to continue on the next video.